Tomorrow will be Polynomials by Polynomials. Okay, so let's get started. Think about this before we do too much. When you add or subtract, what do you do with the exponents? When you add or subtract, you keep the exponents the same. When you add or subtract, you keep the exponents the same. When you multiply, what do you do with the exponents? You add them. So it's not a plain white sheet then. When you multiply, you add the exponents. So make sure you're separating the difference between addition, subtraction, and multiplication. Also, let's notice the difference here from Friday. On Friday, this would have had a addition sign between them. That just means combine like terms. Do you see the addition sign? I'm changing some stuff up here, just so you can see this. Notice that these are just touching here. Do you see how they're touching? That means multiply, and we use the distributive property. Okay. So just make sure you're seeing the difference between those two things, because on the quiz on Friday, they're going to be mixed together, or on Thursday, whichever day it is. They will be mixed together. And the problem with that is that some of you guys are going to start distributing over addition, which makes the problem a million times harder than what it should be. Okay? So there's no point of doing that. So make sure you're checking if it's multiplication or addition and subtraction. This is multiplication, so we distribute. We give the negative 4x to both pieces. So we do negative 4x times 2x plus negative 4x times 3. And I won't be doing all of these steps every single time. I'm just going to start off this way. So negative 4x times 2x. Remember, these x's have 1s on them. Negative 4 times 2 is? Alyssa, negative 4 times 2 is? And Alyssa, x times x is x squared. Okay, negative 4 times 3 is what, Jordan?
Negative 12.
And then what do we do with that x? Just bring it down. Are these like terms? No, one has a square on it and the other doesn't, so we are done with that problem. Again, I'm not going to be showing all this work every single time. I'm doing this so you understand the process. Mike, what's up?
No, that's fine.
Yeah, it's just, for notes, I like to give you guys some idea of what I'm doing instead of you guys thinking that it just appears on the board. Okay. Again, there is no separation of addition or subtraction here, so we use the distributive property. This is multiplication. So I have negative 5x squared times 5x minus negative 5x squared times 3. Two negatives make a... That's a positive there. Okay, Justin Powers. Negative 5 times 5 is... And x squared times x to the first is x to the... Yep. When you do x squared times x, that is x to the... Nope, because it has a 1 here. Third. 2 plus 1 is 3. Yep. And Riley, So 5 times 3 is, and what do we do with that x squared? Are those like terms, Riley?
Yeah.
X to the third and x squared are like terms? No, they have the same base but different exponents. So we are done there. So look at that before you are done. Are those in standard form? Are those written in descending order?
Yeah.
So we are good. Please ask questions if you're confused. I'm not going to show all those steps anymore. I just wanted to do that on the first slide so you knew what I was doing. So when multiplying, you blank the exponents.
Add.
Good. We need to remember those exponent rules. So we are going to add those exponents. Okay, Brian. Notice that these are touching, which makes it multiplication. So we're going to use the distributive property, right?
Yeah.
So I have negative 5x squared times 4. What's negative 5x squared times 4? Good. And Connor? I have negative 5x squared times negative 3x. What is that? X to the... Nope, because there's a 1 on there. 1 plus 2 is 3. Is that in descending order?
Yes.
No, the biggest exponent is a 3, right? The biggest exponent is 3. Descending order means biggest exponent to smallest exponent. So we need to switch those around. Keep the sign that's in front. Those are not like terms. One has a square on it, and the other one does not. You just forgot the exponent. Okay, Jack. What is 4xy times 3y? Yeah, and I'm going to keep that in alphabetical order. Doesn't matter if you write it the other way. I just like mine in alphabetical order. So 12xy squared. Notice the x does not have anything to combine with, so that's why it stayed x. Y times y, 1 plus 1, no, is 2. Connor Clover, what is 4xy times negative 10x? Notice I'm taking the sign that's in front there. So y is squared? You have an x here and an x here. So what is actually getting squared? Yep, so it would be x squared y. Now this is, both of these have a degree of 3. Why do they have a degree of 3? Can anybody explain that? Why do you think they have a degree of 3?
What does that mean?
That's the exponent. Remember, the degree is the highest exponent. We talked about that on Friday. So 3, this is a degree of 3 because it has a 3 on it. Yeah. Why do you think those are degree 3? So 1 plus 2 is 3. 2 plus 1 is 3. Do you guys see that? So you add the exponents there. But we're not going to change those around because they both have degree 3. So it doesn't matter the order there. Is there a huge difference with what is going on in examples 5 and 6, guys? Yeah, but does that change much? No, just make sure we're writing things in descending order in the end. So Cassie, we distribute because, again, this is multiplying. It's not adding. So 7x cubed times x squared is?
7x.
Good. And Grace, 7x cubed times negative 3x is?
Negative 1x.
Yep, there is a 1 on that x, so it's to the 4th. And Mike, 7x cubed times negative 9 is?
Negative 64. Well, actually,
64.
63. No. Oh, wait, never mind. Never mind.
Negative 63 what?
X cubed.
X cubed, very good. Is that in descending order?
Yeah.
Yeah, so we are done. These are not like terms. Can somebody explain to the class why those aren't like terms?
Because they have different exponents.
Yeah, they might have the same base, but not the same exponent.
Doesn't everything have the same base?
Yeah, we try not to do too much without that. Okay, Jayla, 3y times 7 is? Jana, 3y times negative 10y is? Tanari, 3y times 2y squared.
6y.
Good. We have to remember that there are ones whenever there's not an exponent on it. Is that in descending order?
No.
Okay, RC, how would that be rewritten in descending order?
6y minus 30y squared plus 21y.
What did you lose on the 6y?
Or cube.
There you go.
Hurry. You understand this first?
How are you doing, Mike?
Very good. I mean, it kind of got me a little confused when you said
Did you say corn-fused? He did say corn-fused. Okay.
Yeah, you did say.
Okay, moving on. Going on. Continue your
you
sentence.
said a little range 3 or what was it?
Degree.
Yeah, we'll just skip that part.
No, you need to know what that is. That was part of your homework that you were supposed to turn in today. I did teach it to you Friday. Did you turn in your homework today?
She did not. You taught it Friday.
Yeah.
Yes. Yeah. Okay, can you multiply terms with different variables? Is that allowed?
Yeah.
Can you add terms with different variables? No. So you can multiply terms with different variables, but you cannot add them. That's kind of like when we did radicals. Do you remember with radicals, we couldn't add this, right? But we could multiply them, right? Do you guys remember that with radicals? Maybe?
Yeah,
You should, and if you shouldn't. If you don't and you need to retake that part, little refresher here. So we can multiply them. So we will talk a little bit about the degree here as we're doing this. So Kaylee, xy times negative 3x squared is?
Wait, you don't add 3.
You add the exponents.
So negative 3x cubed y.
There you go. So y does not have anything to add with, so it stays. But x to the first times x squared is x to the third. So 1 plus 2 is 3. Okay, Blaine. xy times negative 9x.
Negative 9x to the degree of 2y.
good job, Blaine.
Colin. xy times 2y.
X, Y. Okay, that's gonna be what? 2 to the y, or 2y to the third. I can't say. To the third power.
Y isn't to the third power. Be careful, because we only have how many y's?
I think 2.
You have a y to the first here and a y to the first here. So how many y's do you have? You've already said it.
Yeah, 2.
2, but how many x's do you still have that you lost? What about this x here? Doesn't that just come? So I think you combine, stop it, Connor. I think you combined the x's and the y's together is what you did to get the y to the third. So x's are separate than y's, but they all multiply together, if that makes sense.
Yeah.
All right, so this has a degree of 3 plus 1 is 4, 2 plus 1 is 3, 1 plus 2 is 3. So this is the highest one. These two are the same, so this is a good order. Okay, does that 4x get distributed to the 3x squared? No, it's outside the parentheses. Good. So Justin Crater, 4x times x squared is?
4x to the third power.
Good. And Emma, 4x times negative 5 is?
Negative 20x to
Negative 20x to the third. Be careful.
not the third.
Just negative 20x. It doesn't have an x to combine with. And then we have plus 3x squared. I just moved that down. Is that in standard form?
No.
No, it is not. So how would I rewrite that, Justin Powers, in standard form? Which two are you thinking you can combine?
4x and the 3x.
Do they both have the same exponent? So you can combine them? The answer's no. So the base and the exponent must be the same to be able to combine. So which one has the biggest exponent? So the 4x cubed comes first. Then what comes next?
Oh, and the plus 3x2.
And then the... Good. And that is in descending order. All of the problems. Okay, Lexi, how am I going to do this problem here? It looks a little complicated.
Distribute the 2x to the negative 3x and 7.
Okay, and?
And you distribute the 5 to the x squared and the negative 3 and the 4x.
Good. So that gives us negative 6x to the second plus 14x. Do we have questions on that first part so far? Plus 5x squared minus 15 plus 20x. Look at those numbers and see if anything does not seem right to you or you're confused by how I got any of those.
Can't you combine?
Okay, so what terms are like, Hunter?
Oh. X to the squared and x to the squared.
So x squareds and x squareds are like terms. What are the other like terms we have here, guys?
The not x squared.
So the x is the 14 and the 20. And then this one is all by itself.
Too relatable.
Okay, negative 6x squared plus 5x squared is?
Negative x squared.
14x plus 20x is?
34x.
And then what do we do with that 15?
It goes all by itself.
It's not by itself, it's attached to the other part of the problem.
No, it's by
Okay.
itself. It will never
Connor,
be loved
it's a
by
loser.
Oh, yeah.
Okay, questions on that one? Oh my gosh. Are you doing okay?
Yeah, she's a pro.
Jesus Christ, Connor. That got really dark.
All right. Mike.
I got some Mexican restaurant that I hit it up for.
Okay.
What does that even mean? I don't know. Is it a leftover? I would start at like a minute and a half, depending on how much it is. All right.
We need a shaver that has like.
Guys, the less you talk, the more time you'll have for homework. You guys should be doing fine on this stuff, but you guys talk through me. Please stop talking. I know you do, so let's finish this.
I got this.
All right, Kaylee, what do I do first? What do I distribute?
The negative 6x to 3x squared. Then half. Negative 1/2x.
Yeah, and it's really important that Kaylee said what she did. She took that sign that was in front of it because that is actually a negative half that you're distributing. So, Kaylee, what's negative 6x times 3x squared?
Negative 18x cubed.
And negative 6x times negative 7 is?
42.
Plus 42. What did you forget?
X.
There you go. Okay, Jordan Coward. What's negative 1/2 x times 4x squared?
2x to the third, right?
Yeah, what sign?
Hey, good job.
And then it's plus. No, minus. Right?
Yep, and then Jordan, what's negative 1/2 x times 12?
Oh, 6.
6 what? Negative 6 what? Okay. Do we have any like terms here? Riley.
Yeah.
What are some of my like terms? And what does that become?
That becomes negative 20.
Okay, good. What is my other set plane of like terms?
42x.
Which is? You got there, don't worry. Okay. We have one last problem.
How about let's not do the last?
No, we're doing the last
I
problem.
feel like Connor should do the last.
Find an expression for the Find an expression for the area of the figure. How do I find the area of this figure?
Add all this stuff.
That's perimeter. Base times height. So we do 3x squared times 5x plus 7. If it is an expression separated by addition or subtraction, make sure you put parentheses around it.
Ooh, multitasking.
Notice this word here. Do you guys see it says find the expression?
Yeah.
That means no equal sign. You will not be solving. Do not try to make an equation. It's no equal sign. You will not be solving. So that's because these have all been expressions. There's been no equal sign. So I get 15x to the third plus 21x to the... And we are done. That is our area. Okay, guys, you have the last...